Welcome students. So here is your another chapter, that is application of derivative. So in this chapter, first topic is rate of change of quantities. So let's check the real life uses of application. So first application is this. Now we know what is derivative. What is derivative? Derivative of y with respect to x is given by this limiting value. And what is this limiting value? This limiting value is for a small change delta x. This is the limiting value of this ratio delta y upon delta x. Now if this graph of y is equal to f of x, and 2 points I am taking on the graph, that is P and Q. So distance of P from the y-axis is x1 and from x-axis is y1, and distance of Q from the y-axis is x2 and from the x-axis is y2. Now if I am moving Q to P, that is I am taking this Q towards P, or I can say I am moving x2 to x1. This point x2 moving towards x1, and these two things in other language we can say that is delta x, that is the distance between x1 and x2 tending to 0. I'm not taking the delta x exactly 0, but this is very small quantity such that it is tending to 0. So that time we are studying that changes in y with respect to the changes in x, its limiting value is known as derivative. So what is this? This is a rate of change. We already know that. So rate of change of y with respect to x at a certain time, that is, here is the derivative, that is f dash x. Now check its real life application, that where we can apply this rate of change of quantities. So here is your first problem. So first try to solve and understand the problem, then look for the solution. So here is your first question. Your first question is, find the rate of change of area of a circle with respect to radius when r is equal to 3 centimeter. What you have to find? Rate of change of area, that is rate of change of area with respect to radius, that is dA dr. You need to find dA dr when r is equal to 3 centimeter. Now what you have, that r is the radius and a is the area. Now what is the relation between a and r? A is equal to pi r square for circle. The area is pi into radius the whole square, that is pi r square. Now differentiating this equation with respect to r, both sides, that is dA dr, I can write, just apply the x to the power n formula. So we will find that is 2 pi r. So from here I can write this ratio of change is given by 2 pi r. Now this ratio at r is equal to 3. The value is 6 pi. 2 pi into 3, that is 6 pi. So hence the rate of change of area with respect to radius is 6 pi square centimeter per second. So here is your answer. So check the answer, that is the rate of change of area with respect to radius is given by centimeter, square centimeter per second. Since the radius and the area are changing with respect to time, definitely. So here is your next problem. So let's check what is given. the radius of a circle is increasing uniformly at a rate of 3 centimeter per second. So this rate is given centimeter per second. So dr dt is given 3 centimeter per second. That is the change of radius with respect to time. We need to find the area of the circle is increasing. The rate at which the area of the circle is increasing. That means we need to find dA dt, that is the rate of change of area with respect to time, at r is equal to 10 centimeter. When r is equal to 10 centimeter, that time I need to find this ratio or the rate. Now we all know the relation between A and R, that is area and the radius of a circle, that is pi r square. So what is dA dt? Differentiating both sides with respect to t, we will get, so we will apply chain rule. Since this area is a function of r, so we just differentiate this with r, and as per the chain rule, so dr dt, I'll write next. So pi r square, derivative of this 2 pi r into dr dt. Now I have the value of dr dt. So it is 3. So 3 to the 6 pi r. So if it is 6 pi r, now we need to find dA dt, that is the rate of change of area with respect to time at r is equal to 10 centimeter. That is, when the radius is 10, then the change of area we need to find. That is 6 pi into r. R is 10. The value is 60 pi. Definitely the unit is centimeter square per second. Here is your solution. You can check. That is, the rate of change of area with respect to time at r is equal to 10 centimeter is given by 60 pi centimeter square per second. So let's check another example. A stone is dropped into a quiet lake and the waves move in circles. So wave moves in a circle. From the picture you can say, if the radius of the circular wave increasing at rate 4 centimeter per second. So what is given? The radius of the circle increases at a rate 4 centimeter per second. So dr dt is given 4 centimeter per second. So find the rate of increase in its area at the instant when the radius is 10 centimeter. Here also you need to find the area changes in the area, that is the ratio dA dt or the rate of change of area with respect to time when r is equal to 10 centimeter. Similar manner, just find the dA dt, that is A is pi r square. Then differentiating both sides with respect to t, we will get, by the chain rule, it will come 2 pi r if we differentiate this with respect to r, and as per the chain rule, dr dt will come. And we know the value of dr dt, that is 2 pi r into 4, that is 8 pi r. Now we need to find when the radius is 10 centimeter, then what is the rate? So dA dt when r is equal to 10 centimeter. So that time 8 pi into 10, that is 80 pi. So 80 pi centimeter square per second is your answer. Here is the solution as given. You can check the solution. Okay. So moving to the next problem. the surface area of a spherical balloon is increasing at a rate of 2 square centimeter per second. So here what is given? The surface area. If the surface area is S, then the rate of change of surface area with respect to time is given 2 centimeter square per second. At what rate the volume of the balloon increasing when the radius of the balloon is 6 centimeter? So what you need to find? You need to find dV dt when r is equal to 6. So let's check. The surface of a sphere is given by S is equal to 4 pi r square. We all know that the surface of a sphere is 4 pi r square, where r is the radius. So what is ds dt? Differentiating both sides with respect to t. That is, by the chain rule it will come 8 pi r, that is r square is 2r, that is 2 into 8, this is 2 pi r, into dr dt. Now what is dr dt? Dr dt is ds dt, that is 2 divided by 8 pi r. So if I calculate this, that will come 4 pi r, 1 by 4 pi r. Now we need to find dV dt, that is the rate of change of volume. So what is V? dV dt is given by d dt of volume. Volume is 4/3 pi r cube. So if we differentiate this value, so it will come 4/3 into pi into 3r square into dr dt. So put the value of dr dt, and ultimately the value will come 3 cancel, that is 4 pi r square into 1 upon 4 pi r. 4 pi cancel, only the remaining value is r. Now you need to find the rate of change of volume when r is equal to 6. So put here the value is 6. So the answer will be 6 centimeter cube per second. Here is the solution. You can check. Write down the answer. That is, the rate of change of volume with respect to time is 6 centimeter per second. Here is your next problem. The volume of a cube is increasing at a rate of 7 centimeter cube per second. So here the increase rate of volume, that is dV dt, is given 7 centimeter cube per second. How first is its surface area increasing at the instant when the length of the edges of cube is 12 centimeter? Here you need to find, that is ds dt, that is the rate of change of surface area with respect to time when this x is given 12 centimeter. That means the edges of the cube is 12 centimeter. So for cube, what is the volume? dV dt is, what is V? V is x cube. So differentiate this, 3x square dx dt. Now we know the value of dV dt. So find the value of dx dt. dV dt is 7. So 7 upon 3x square is the value of dx dt. Now what is the surface area? S is equal to 6x square Now differentiate this with respect to t, both sides, so we will get 6 into 2x. So differentiating this value with respect to x, and as per the chain rule, it will come dx dt. So put the value over here, that is 12x into 7 by 3x square. So ultimate value will come 28 upon x. So now you need to find ds dt when x is equal to 12 centimeter. So put the value here, 28 upon 12, that means 2 and 1/3 centimeter square per second. Here is your answer. Here is your solution. You can check. So moving to the next problem. The side of an equilateral triangle increasing at a rate 2 centimeter per second. So side, that means dx dt is 2 centimeter per second. Now you need to find the rate of change of area. Now what is the area for equilateral triangle? That is root 3 by 4 x square. So now differentiate this with respect to t, that is dA dt is equal to root 3 by 4 into 2x into dx dt as per the chain rule. First of all, find the derivative with respect to x, then with respect to t. So what is dx dt? Dx dt is given. So that is root 3 by 2. 2, 4 cancel. That's why 2 into x into 2. Again 2 to cancel. So root 3x. So dA dt is root 3x. Now we need to find dA dt when x is equal to 10. dA dt when x is equal to 10. That means 10 root 3 square centimeter per second. Here is your solution. You can check. So moving to the next application. So here a triangle is given, that is A, B, C, where given that AB and AC both are equal. Okay, and the base B, that is BC, is given B, decreasing at a rate of 3. That means it is given that this sides, that is AB and AC, the sides, if we take x, so dx dt is decreasing at a rate 3 centimeter per second. Now the area is decreasing when each of the equal sides is equal to the base. That means these two equal sides will be equal to B. That time you need to find the rate of change of area. So if I take this point is D, then find first AD, that is root over x square minus B by 2 the whole square. This value, since this is B, the half of it is B by 2. So this value will come root over 4x square minus B square by 4. So now you need to find the area. So the area is half into base into height, that means AD. So here it is 4x square minus B square by 2. Now differentiate this with respect to t. So dA dt So ultimately, apply the chain rule, you will find this is b by 4 and derivative of this root over x square, 4x square minus b square. So half of 4x square minus b square to the power minus half into derivative of 4x square is 8x, and according to the chain rule, dx dt will come. Now here is the value of dx dt is given. So ultimately, if we calculate it, the value will come like that. Three bx upon root over 4x square minus b square. Now put the value when this each sides will be equal, that is x is equal to b. So put x is equal to b here, you will find your value, that is the rate of change of area. So that will be centimeter square per second. So write down the answer, that is rate of change of area with respect to time is this when the sides are equal with base. So let's solve some homeworks. Here's 3 problems are given. There's 3 questions. So try to solve these questions. If any problem or any doubt is there, you are free to ask. Thank you.